ahead and get a blank whiteboard going, just in case I need a spot to show my work. Now I'm going to jump onto YouTube so that I can actually see if I'm live, because you never know. I've had an awful lot of tech problems. Okay, so it does say that I'm live. That's nice. So I'm going to go ahead and jump over to Desmos. And it's about a minute before we're going to get started. This is going to be my office hours for today. I'm not going to do extra office hours after this. People haven't really been showing up to the live office hours anyway, so we're going to have to figure out a way to address that, but I don't think anyone's going to show up regardless if I had them today. So let's do this thing. This is the assignment that I gave, I think yesterday. I'm going to leave the assignment up, so folks who watch this video and use it to finish the assignment, I'm actually okay with that. I'd rather you get the work done than not. There's a bird right outside my window making very loud noises. I apologize if that is bothersome. I haven't like soundproofed this place. Okay, so here we are. Let's do a little bit of zooming. There we go. Okay. So this is an introduction to the equation of circles. Circles, just like anything else, can be graphed on an XY axis. We are not used to graphing things that aren't functions. It's clearly not a function, right? The vertical line test has failed basically everywhere. But we can come up with an equation, and we can graph that equation. And that's always helpful to be able to have a symbolic way of denoting a particular circle. Okay, so the first place I'm going to direct your attention. I apparently cannot move that around too much. Take a look at this equation on the far left. It says x minus h squared plus y minus k squared equals r squared. This is going to be the equation that we are working with the entire time. So you might want to note that down because we're going to be using it a lot. Okay, so the question says, what do you think r represents? So that's this r right here. And what do you think happens when r changes? And then it gives us this slider so that we can move r up and down and see what happens. Okay, well, that's pretty simple. When I move r up, it makes the circle bigger. When I move r down, it makes the circle smaller. Can we be more precise than that? Let's see. If I put in r equals 2, what is the... Whoa, that was weird. What is the radius of my circle? I've got this, it's centered at 0, 0. And there's the radius. Its radius is 2. What if I made r 4? Well, now the radius is 4. What if I made r 10? Well, now I can't see it at all because it's too big. But hey, look, it does have a radius of 10. I wonder what happens if I put in a negative number. Weird. It shouldn't do anything. Oh, how about this? Yeah, that shouldn't show anything because obviously it's not a real number if you take the square root of a negative. I don't know. Okay, so what does r represent? What happens when r changes? These kinds of questions are really important on these Desmos activities. Okay, it looked to me like r represents the radius of the circle. What happens when r changes? Well, when r changes, the circle got bigger and smaller. The circle gets bigger and smaller when r changes, and we weren't sure about why we were allowed to do r as negative, but who knows? Submit. Okay? So now we're going to move on to the next frame. Now it's asking, same equation, x minus h squared plus y minus k squared equals r squared. We'll talk more about where this equation comes from in another video, but for now it's asking what happens when h changes. Okay, so h is this number, this variable right here in there with x. And I have been using h and k specifically in our class on purpose because I wanted you to get to this point right here, this spot in the curriculum, and remember that h moves the circle horizontally. If I make h bigger, the circle moves off to the right. If I make h smaller, the circle moves off to the left. That make sense? So h is a sort of left-right value. If I move h over to 1, you can see that the center of the circle is at x equals 1. If I put it h equals 3, the center of the circle is at x equals 3. If I put h equals 0, the center of the circle is at x equals 0. I know I'm belaboring the point, but this is brand new curriculum, so I'm going to take this one very small baby step at a time. Okay, so what does h represent? H is the x value of the center. What happens when h changes? When h changes, the circle moves left-right. Or word it however you want. You can even be more specific about this and say that when h is positive, you move to the right, and when h is negative, you move to the left, which some of you are immediately getting warning lights in your head going, wait a second, I thought it was opposite. It is, but it isn't. Don't worry, I'll cover it. Oh, I'll hit the submit button. And remember, by the way, with these Desmos activities, you can always edit your response later. Like, you're not locked in. Okay, obviously, what do you think k represents? I'm pretty sure anybody who has watched this far probably has a pretty good idea of what k is going to do. That's the number in here with y. And what it does is it moves the circle up and down. So with a combination of h and k, we can move the circle anywhere we want. We can translate the circle. There's a good vocabulary word. We can translate the circle wherever we want. I have one viewer at the moment. If at any point you have any questions, feel free to drop them in the comments or in the chat. It'll take me a while to see them, but I will go ahead and address it when I see it. So what does k represent? K is the y value of the center. When k changes, the circle moves left and right. Challenge number 1. Drag the sliders so that the red dots are inside the circle and the purple dots are outside the circle. Now let's make that a little bit easier to see. All right, so I'm going to move h and k around so that it contains all of those red points but doesn't contain any of the purple points. So let's see, let's move it to the right a little bit, maybe move it down. And we'll make it bigger, but not too big. There we go. So the R made it bigger, the H and the K moved it around. And now I have a circle that has all the red dots inside it and all the purple dots outside it. I'm sure there's more than one way to do this. I'm sure that there are other values of H and K and R that would still solve this. Any one of them is fine. Okay, so what is the center of the circle you just found for challenge 1? Let's see, 1, 2, 3, and negative 1, 2, 3. So 3, negative 3. So A, the center is 3, negative 3. How does this relate to H and K? Look at your sliders. Okay, well, let's back up and look at those sliders. H was 3, and K is negative 3. So like we said before, HK as a point is the center. I'm going to be restating this idea several times over the next 15 or 20 minutes. Because again, this is brand new to most of you, but it's not brand new. This idea of using H and K to move a parabola around or a line around is something that you've done. Point slope form was like that, and manipulating parabolas. Okay, C. What is the radius of the circle that you found? Let's see. Here's the center. All you got to do is count out in any direction. 1, 2, 3, 4, 5. So I've got a radius of 5. How does this relate to R on your slider? R was also 5 there. Let's double check that. Yep, there it is. R equals 5. So we're going to dig into the details of exactly how this works, but in general, you've got 3 things other than x and y. The equation is x minus h squared plus y minus k squared equals r squared. And each of those letters, h, k, and r, has its own effect on the graph of the circle. Okay, this says copy into your notes. So I'm going to sit and stare awkwardly at the camera for a moment, and those of you who watch this later, hopefully you will pause the video here and write this in your notes. Okay, the standard equation of a circle with a center at hk and a radius r is x minus h plus y minus k, squared, don't forget the squared, x minus h squared plus y minus k squared equals r squared. So if I wanted to have a circle centered at 0, 0, with a radius of r, as it says, that would be x minus 0, because h would be 0, and k would be 0, and r is just r. So you would get x minus 0 squared plus y minus 0 squared equals r squared. Well, that's what this says, right? X minus 0 squared is x squared. They're the same. So if I wanted to find a circle that had a radius of 4 and it was centered at 0, 0, it would be x squared plus y squared equals 4 squared, which is 16. Okay. Halfway through. Identify the radius and the center in this picture. All right. Well, once again, let's take a second. Can I zoom in? I can a little bit. See if you can identify the radius and the center, not necessarily in that order. The center is probably the first thing to find. Well, I can eyeball the center pretty easily, but if you can't, you can always choose one of the outermost points. I mean, they're all the most outermost point, but you can sort of split the difference between the two if you find a diameter and kind of count in the middle. I think that this right here, which is 1, negative 1, negative 2, negative 3, negative 4. I think it's 1, negative 4 is the center of this. And then the radius, Well, let's see. From the center, I go up 1, 2, 3, 4 to get to the edge. So the radius is 4. Okay, now we're given an equation. Identify the center of the circle in this equation. Identify the radius of the circle in this equation. Now we have to be careful here. Remember that the equation is x minus h squared, right? X minus h. So what's h? Well, h is not negative 7. H is 7. Because again, this piece of the equation is x minus h, x minus 7. H is 7. H is not negative 7. If h was negative 7, then you would have x minus negative 7, which is the same thing as x plus 7. I will be restating this idea a lot in the next few minutes. So again, if you don't get it right now, don't worry about it. H is 7. Okay? How about k? Again, this section here, this little y plus 5 squared, that is y minus k squared. Y minus k. So k has to be negative 5 because y minus negative 5 is the same thing as y plus 5. So k is negative 5. This is finally where that whole reversal thing comes from. When we were working with parabolas and you moved them left and right and up and down, just like you're doing right now with the circles, a lot of you expressed confusion regarding why it was that you move to the left when you seem to have a positive number, right? This y plus 5 actually moves it down 5. But that's because it's not really y plus 5. It's y minus negative 5. Negative 5 is k. That's why the graph is being moved down 5. So the center is 7, negative 5. Hey, really quick, what's the radius? If you just said 4, then I totally understand where that number came from, but remember that 4 isn't r, it's r squared, right? Again, for the probably 17th time, x minus h squared plus y minus k squared equals r squared. So r is the square root of 4, which is 2. This is a circle that has a center at 7, negative 5, and a radius of 2. Write the equation of the circle shown by replacing h, k, and r with numbers. Make your circle blue. Well, I don't necessarily know how to change the color of my circle, but let's give this a shot. So this circle looks like it has a center at 4, negative 1. Keep in mind that each of these squares right now is worth 1/2, not 1. So this looks like the center is 4, negative 1. So that tells me it should be x minus 4, right? X minus h squared. Oh, and hey, look, there is a parabola. If I just do x minus 4 squared, I'm given a parabola that has been moved 4 spaces to the right. So that's kind of a neat throwback. Plus, now the y value of the center is negative 1, so that's going to be y minus negative 1, which is the same thing as y plus 1 squared. Equals. What's the radius? Well, if I go from the center and remember that each of these squares is worth 1/2, my radius is 1, 2, 3. So I can say 3 squared. And hopefully you can see that the two circles overlap one another. Instead of saying 3 squared, you could have just said 9. Still works. I mean, 3 squared and 9 are exactly the same, so that's fine. Write the equation that you came up with on the previous slide. Now, when I did this, I was like, do I really have to type that again? I actually checked, can I copy and paste? And the answer is yes, I can. So there's a tip for you when you do Desmos activities going forward. A lot of the time you can copy and paste. Now, I'm going to skip this one because this is the exact same circle. You see its center is 1, 2, 3, 4, -1, and its radius is 3. I don't know why it's got the same circle twice. I probably put this in intending to change it, and I didn't, so we'll move on. Write the equation of a circle that has a center of -2, 1, and a radius of 3. Okay. So it's going to be x minus h, but h is -2, right? So it's going to be x minus -2, which is the same thing as x plus 2 squared. And again, I know this equation because I've been doing this a lot. You should have the x minus h squared plus y minus k squared equals r squared equation written down on a piece of paper next to your computer while you do your homework, because all I'm doing is taking the values that I'm seeing and substituting them into that equation. This is stuff that you've been doing since pre-algebra or 7th or 8th grade or whatever. All I'm doing is taking out the x minus h, I'm taking out the h, and putting in a -2. X minus -2 is x plus 2. Plus y minus 1, y minus k, squared, equals, the radius is 3, 3 squared is 9. Verify that your equation was correct by typing it below. Once again, I'm going to take the lazy way out, and I'm going to copy and paste. Now, it was supposed to have a center at -2, 1, right? So here's -2, 1. That's definitely the center of the circle. And it was supposed to have a radius of 3. 1, 2, 3. I see 3. So it looks to me like we got this. Write this down in your notes as an example to refer to. So example 1. Write the equation of the circle, and then it gives a graph of the circle. Now, I actually would do this a little bit differently. My first step, because the origin is 0, 0, in this first line here, instead of going straight to x squared plus y squared, I would actually write x minus 0 squared plus y minus 0 squared. The center is 0, 0, so h and k are both 0, and I would write that down to remind myself that they're there, even though in a second I'm going to get rid of them because plus 0, I mean, who cares about a minus 0? Equals radius, which is 1, 2, 3, 4, squared. So my first line would say x minus 0 squared plus y minus 0 squared equals 4 squared. And then, yes, x squared plus y squared equals 16 is the equation. You can go on Desmos right now if you want and type in x squared plus y squared equals 16. You will get a circle that is centered at the origin and has a radius of 4. Write an equation with a radius of 5 centered at -2, 3. So again, I really like what this does. X minus -2. X minus h is -2, k is 3, r is 5. X minus -2 squared plus y minus positive 3 squared equals 5 squared, and then you simplify that to x plus 2 squared plus y minus 3 squared equals 25. I believe we have only one more of these slides to go. Another example for you to write down. If you are required to graph a circle, now while we're distance learning, you'll be graphing on Khan Academy, which I think you've already done at one point in an assignment recently. But if you were doing this on a piece of paper, a compass would probably be the best way to go. Otherwise, I don't know about you, but I make really ugly circles when I try to make them through 4 points. It doesn't work for me. So a compass is usually the best. If I have x plus 1 squared plus y minus 3 squared equals 4, okay, well, h is negative 1 because this x plus 1 is the same thing as x minus negative 1. K is 3, so the center is negative 1, 3. And on the other side of the equals, 4 is r squared, so the radius is 2. So we take an ordinary pencil, I suppose, and make a dot at negative 1, 3. And then you would open up the compass until it was 2 units wide, and you would make that circle. Now, this is kind of backwards for me. Usually I start by telling you where the formula comes from, and then I show you how to use it and what all the pieces mean. This time I'm going the opposite. You should be able to do all the Khan Academy for this week at this point. On Monday, I will start off with a video about why is this equation what it is. Why is it x minus h squared plus y minus k squared equals r squared? And actually, the reasoning comes right from right triangle trigonometry, so we're kind of going to blend everything all together and mush it all up, just like math always does. So I hope this video was informative for you. I know it's longer than usual, but again, this is a brand new topic, and I want to make sure I cover it very thoroughly so that everybody gets a chance to do this. Because brand new topic means that the early assignments are going to be easier. At least that's the theory. We'll see. Thanks for watching. Class dismissed.